Good afternoon everybody, and here we are back with another session of Mathematics IGCSE, and this is term 2 and it's the first week and it is session 2. I've got a challenge question for you. How many 11s are there in one whole? 2 challenge questions. There's another one. Even more difficult. How many 47s are there in one whole? At the end of the lesson, you can phone in and let us know how many 11s and how many 47s, and there will be a prize for the winner. It will be 5 minutes holiday at Broncos Break. Okay, right. And we carry on now. We need to be able to change mixed numbers into improper fractions with this word. And the way that we do it is, I won't go into the theory of it, but we use a drill. If we have 7 3/4, you have to be able to do this without thinking. It's a drill. Like left, right, okay? 7 3/4 is a mixed number. We know it's a mixed number because there's not a multiplication sign here, there's not a dot here, there's not a bracket here. That's why there's actually an invisible plus. That's why we say 7 3/4. 7 3/4, we multiply the bottom one by the whole number, and then we add the top one. So 7 4s are 28, 29, 30, 31. So this is equal to 31, and we keep the 4. 31/4. That's how we change a mixed number to an improper fraction. And improper fractions are much more useful to us in maths than mixed numbers. Mixed numbers, engineers use them when they measure the thickness of something. It's so-and-so and a quarter, but they can't do maths with it. You have to change it usually to an improper fraction. Okay, right. Now we carry on to addition of fractions. How do we add fractions? Let's just go through a little bit about fractions first. Every fraction has a numerator on top. That's the number of how many. And then a denominator, I think I'll make this an E, at the bottom. That's how many and that's what name. Okay? So, let's see if you can add these fractions. We've got here 5 apricots. And we've got 2 fleas. What's the answer? Okay? Well, we know there's 7, but there's 7 what? 7 stuff. 7 stuff. So, you can see this doesn't make sense. If you had to email this to somebody in Russia who's making a bomb, he wouldn't understand what you want. Okay? You have to have the same thing at the bottom when you add in fractions. So, let's go to some easy fractions to add. 2 7s plus 3 7s is how many 7s? The 7th has to stay the same. Doesn't change when you're adding them when they are the same denominator. We've got 5 7s. Very easy to do when your denominator is the same for all the fractions. But if it's not the same, you have to make it the same. So if we go to add 3/4 and 5/6, we've got to do something to the 4 and the 6 to get the denominator the same. So what do? We're looking for the highest common multiple. Okay? Now don't break your head over that. Just think it through. What can we multiply? What's the smallest number we can multiply 4 and 6 by so that they're the same. What does 4 and 6 tell us? What number can you see in your head when you hear 4 and 6? What is it? 12? Yes. 4 and 6 are both factors inside 12. Not prime factors, just factors. Okay? So if we multiply 4 by 3, we're going to get 12. If we multiply 6 by 2, we're going to get 12. But what we do at the bottom, we've got to do at the top, like that. And then this gives us 9 over 12 plus 30 over, sorry, this has got to be 2. 2. This has got to be 10. 5 times 2 is 10 over 12. Okay? Now we can add them. This is 19 over 12 or 19/12. Very easy. And that is how we add fractions if we need to make the denominator the same. Okay? Sometimes you need to only multiply one of them by, for instance, if this was this was a quarter and that was 8, then we would multiply this by 2, this by 2, and then we would have 8s at the bottom. Then we could carry on like that. We didn't need to multiply the 8. Okay, so now we're going to add a more challenging one. We got here 2 and 5/8 minus 1 and 3/4. First thing to do, change the mixed numbers to improper fractions. 8 to the 16, 16 and 5 is 21 over 8 minus 4 ones are 4 and 3 is 7 over 4. Now we need to get the denominators the same. This 8 is alright, but that 4 is not. So we can say 21 over 8 minus, going to multiply by 2 here. 2 at the top, 2 times 7, 14, 2 times 4, 8. Now we got 21 minus 14 over 8. 21 minus 14, 20 minus 14 is 6 and 1 is 7. 7 over 8. And there's our answer, 7/8. Okay? And it's all done with the human brain. Okay? No cathodes, no diodes, no transistors. Very powerful instrument. Now we're moving on to the next section. By the way, this is section 5.3 and 5.4. Most of the syllabus are divided up into 2 exercises or 2 sections per session. So the first session was 5.1, 5.2. This is 5.3, 5.4. The next subsection here is dividing fractions. How do we divide fractions? Okay. What is 2 divided by a half? Do you know? Without getting all mathematical, how many halves are in 2? 1, 3, 6? No, there's 4. Because each one has 2 halves, and there's 2 of them. So that's 4. Wow. How, and what is, okay, how did we do that? How could we do that mathematically? It's actually 2 divided by a half. I like to use fractions to divide. This fraction line is the same as that dividing line. This line here, so as not to confuse you. Okay, 2 divided by a half. What do? We take the half from underneath and we turn it upside down and we multiply. So a half turned upside down is what? It's 2 over 1. So we multiply by 2 over 1. And that is actually 4. Okay. So when you want to divide by a fraction, very easy. Nobody can divide by a fraction without cracking his head. So the best thing is just take the fraction at the bottom, turn it upside down and multiply. Then it's easy. So let's do the opposite. What is a half divided by 2? How many 2's are there in a half? Now if I had to ask you that question, it would be at a Wednesday. Okay? So I don't really know how many 2's are in a half. There's not many, I can guarantee you. So a half, let's write it like this. A half divided by 2. A half divided by 2. Okay, what is 2 actually? 2 is actually 2 over 1. Okay, so we can put the 1 in there. Now we want to write this division, half divided by 2 over 1 or 2. We want to change it to multiplication. A half times, now we turn it upside down, 1 over 2. Now we can multiply. It is a quarter. This method always works, and you have to just realize that all your whole numbers are can actually be written as the whole number over 1. And it's very important to keep a line in the middle of your working, an imaginary line, so that your fractions have a top and a bottom, and your equal signs goes there, and a 7 over 1, which is not true, okay, but you cannot go having you can't say 6 times 1 over 2 or 6 times 1 over 2. That is very confusing, because that looks like 1 over 6 times 2, which is equal to 1 over 8, which is not. This is 6 times 1 over 2. This line is in the middle. Yes, your line. Okay? So make sure you always know what's top and what's bottom. Okay? Now we'll just do some slightly more challenging examples quickly. 2 over 5 divided by 3 over 7. All you do is you say, this is the one just after the divide sign. That is the only one that is turned upside down. Even if you've got a long row of times and divides and times and divides, only the one just before the divide sign, just after the divide sign. That's the one you turn upside down. So this is 2 over 5 multiplied by 7 over 3. Easy. 7 times 2 is 14 over 15. There's your answer. Okay. Last example now. This is where it starts getting tricky. So you need to do all the exercises so that you can get lots of practice. Otherwise, you're going to take too long with the sums. So, by the time you've done all the exercises, you'll be able to do this. 2 and a third minus 1 and 2 fifths. They put in brackets here for us so as not to confuse us. If there were no brackets, we would first divide these two, taking account of the minus sign, and then we would bring this one in as an addition or subtraction. So now with brackets, we know we have to do this first. Easy. Watch the drill. 2 times 3 is 6 and 1 is 7 over 3. Minus 5 times 1 is 5 and 2 is 7 over 5. Okay? We keep the brackets because we're not finished with this yet. Divided by a third, we can already turn it upside down. Multiplied by 3 over 1. Okay? Now we want to subtract this, but we don't have lowest common multiples. Yeah, this 3 and this 5 have nothing in common. When you have that, multiply them with each other. That's the simplest. So we're going to multiply the 3 with a 5 and the 5 with a 3. 5 3s are 15. 3 times 5 is 15 underneath there. Now we got to multiply the 7 with 5. 7 times 5, 35. Minus 3 times 5 is 15. 3 times 7, 21. Okay? Brackets times 3 over 1. Brackets first. Subtract. Now we can subtract. This 50 is not going to change anymore because we've got a subtraction. There's no difference between a subtraction and an addition. It's just the sign. So 35 minus 21 is 1. 3 minus 2 is 1. 5 minus 1 is 4. It's 14 over 15. Now we can leave our brackets out, multiplied by 3 over 1. And there we go. I don't know my 14 times table, so I'm going to simplify this. 3 goes into 3, 1. 3 goes into 15, 5. And my answer is 14 over 5. Usually I prefer to leave it like that because if I'm going to do more maths with it, I don't want a mixed number. But most of the time, I don't think they will subtract marks if you leave your answer like that. So, next time or when appropriate, we'll learn how to change an improper fraction into a mixed number. Okay, cheerio.